Okay, so good afternoon to everybody and welcome to session number 8 of vectors. So we're going to start with understanding some applications of dot product again through the worksheet number 6 that we were discussing earlier. I mean that I had given you to solve earlier, and we'll start with the discussion of the questions, some of the questions from that worksheet. Okay. So before that, let us start with a quick recap of the concepts that we learned in the last time to do with three-dimensional vectors. So first of all, we started last time with understanding the concept of direction cosines. Okay, for a three-dimensional vector in component form. So we saw if the vector is given in terms of this, then the direction cosines are given by these relations. Where we understand that alpha, beta, gamma are any angle between 0 and 180. Okay, because it's just the magnitude of the angle with respect to the XYZ axis. There is no sign convention as such over here. Okay. So that is about this. Okay, then we had also seen that these are the direction cosines. Then direction cosines have that important property that cos square alpha plus cos square beta plus cos square gamma always equals unity. Okay. Now, one additional concept that we learned today plus cos gamma k cap, right? We get this because that you can understand by just using these equations. You can understand, which is basically what we call a cap, okay, or the unit vector along the vector e. Okay. So this is an additional little concept that we learn over here today. That given any vector, we can define its unit vector. So, and that unit vector is nothing like this. So, for example, if I have a vector b, which is let's say 2i cap plus 2j cap plus let's say 2 root 2 k cap. Okay. So you can see from here that magnitude of b is becoming square root of 2 square plus 2 square plus 2 root 2 ka whole square. Okay. So that is square root of 4 plus 4 plus 8. So that is 4. Okay. So we can see that b cap is nothing but 1 by 2i cap, or let me write it as a formula first, then I'll come back to what it is. So b cap, which is the unit vector along the vector v, is nothing but the vector v divided by its own magnitude. So the vector b divided by its own magnitude here will become 2i cap plus 2j cap plus 2 root 2 k cap divided by 4. So this quantity here will become 1 by 2i cap plus 1 by 2 j cap plus 1 by root 2 k cap, which is the unit vector along b. So this quantity here now, it becomes, you can say, this B cap is the unit vector along the vector, and each of the components are nothing but its direction cosines. So this is a little bit of an extension of the concept that we learned last time. Okay. Just a little bit of extension of that concept. From direction cosine. So just make a note of this and we'll discuss some applications and important aspects with respect to this. Hope you also got a chance to go through your test question set through the website. The test you had given on last Sunday, the question set of that, I hope you got a chance to go through it. And from that, any questions you might not have attempted or may not have been able to solve, you have solved them out now. If any difficulty remains in any of the questions from the test paper, please do send them across to me. I'll help you out with those. Especially if anything in vectors. Varun, discussion of assignment 5, I won't be doing in detail because it was a revision worksheet. Okay. But you can send me the individual questions. Whereas I will be doing the discussion of worksheet number 6, which I sent last time, which is to do with the dot product applications. No, Manas, to answer your question, A cap means not mod of A. A cap actually means unit vector of A. Okay. So the quantity A cap, this thing, is actually this. It is the unit vector along the vector A. So that's what this example is. Suppose I've given you a vector B, which is some x I cap plus y j cap plus z j cap. Then B cap is the unit vector of B. Okay, good. Right, so let's continue further with this now. So this is what we mean by the unit vector of one vector. So another point we'll understand here from this is that if two vectors are parallel to each other, if two vectors happen to be parallel to each other, then their direction cosine should be same. Okay. So let us understand this statement, and from this we'll get an easy way to check for parallel vectors. Suppose I am saying in 2D. For example, in 2 dimensions, in the xy plane, I have first drawn this vector E, which is like this. For this angle is theta. Okay. So therefore, for the vector E, we can say alpha, that is the x-axis, the angle with the x-axis is theta. Beta, the angle with the y-axis will become 90 degrees minus theta. And gamma should be equal to 90 degrees because it's in the xy plane. Okay. Now, if I draw another vector, say the vector B like this, this is at an angle theta prime. So for B, you can see that alpha is equal to theta prime, beta is equal to 90 minus theta prime, and gamma become equal to 90 degrees. Okay, now for E and B to be parallel, you can see that theta should be equal to theta prime. And the moment that happens, alpha prime, let's say these are all prime. So all these angles should be equal. This becomes a necessary condition in terms of direction cosines. Because this is a two-dimensional case, so we might not think in terms of direction cosine. We might just think in terms of angles. So it's just enough to say that theta is equal to theta prime. But अगर उसको मैं अभी direction cosines के terms में लिख रहा हूँ, so it will mean this condition. Okay, so it will mean that cos alpha is equal to cos alpha prime, cos beta is equal to cos beta prime, and cos gamma will be equal to cos gamma prime. This is the condition for parallel vectors. So in the above example, now in component form, suppose if vector E was equal to Ex I cap plus By j cap, and vector B in component form was Bx I cap plus By j cap, then Ex upon E should be equal to Bx upon B, and Ey upon E should be equal to By upon B. This is the condition for parallel vectors. For the vectors A and B to be parallel, this becomes a condition. Statement 1 here plus statement 2. So just make a note of this, then we'll discuss more about this parallel condition thing. So we'll come to this in 3D also. Okay, so I'm just scrolling down now here. So you see, when you implement this, that for them to be parallel, theta should have been equal to theta prime. So that means their direction cosines are all same. In this case, of course, the z wala direction cosine is anyway equal to 0, because gamma and gamma prime are both 90 degrees. But the condition for alpha and beta to be equal, so cos alpha is equal to cos alpha prime and cos beta is equal to cos beta prime. That gives us this relation. So now let us extend this concept to 3D vectors. So we'll see. So for vectors in 3D, if A is parallel to B, implies that Ax upon A is equal to Bx upon B. AY upon A is equal to BY upon B, and AZ upon A is equal to BZ upon. So all three equations have to be simultaneously satisfied. Okay, this, and this. Okay. So now if you combine the equations, we can also express it in this way. Okay. So all combining equation 1, 2, and 3. Okay. So you can see AX upon A is equal to BX upon B. AY upon B is equal to like this. So if we say that vector A divided by its own magnitude, that will give us what? It will give us AX upon A I cap plus AY upon A J cap plus AZ upon A K cap. This must become equal to what? Vector B divided by its own magnitude. Because this quantity is equal to now this quantity, Bx upon B, which is plus By upon B J cap plus Bz upon B. So in other words, equation 1, 2, and 3 को अगर मैं combined form में लिखता हूँ, that just put an I cap on both sides in equation 1, put a J cap on both sides of equation 2, and put a K cap on both sides of equation 3, and add them up. So we'll get this. So now this you can see is the condition, in other words, of saying that vector A divided by its magnitude must be equal to vector B divided by its magnitude, which is basically as good as saying that A cap is equal to B cap. And now if you think about it, this makes total sense. If two vectors are parallel to each other, then the unit vectors must be same. If you reduce both the vectors magnitude to unity, they are basically the same vector. So if A is parallel to B, their unit vectors should be the same. Should be the identical unit vector. Okay, so that is how we can express the parallel condition by using, to begin with the concept that for vectors in they are parallel, direction cosines must be equal. Okay. So that is what we have expressed here in equation 1, 2, and 3. And then combining that the fact that the direction cosines are equal into a vector equation, that just means that vector A divided by its magnitude must be equal to vector B divided by its magnitude, which basically means that they have the common unit vector. Whatever the unit vector of A is, the same is the unit vector of B. Okay, Hardik, no problem. Kanak and Hardik, you can join again. I will put you back from the waiting room. Okay, so this becomes a condition for two vectors to become parallel to each other, that the unit vector should be same, or in other words, their direction cosine should be identical. All three direction cosines should be the same. Yeah, here we are combining all three. We have combined the z-axis component also. Az upon A should be equal to bz upon B. Okay, so on request of a couple of students, I am just going to the earlier thing to understand this condition for 2D, and then we'll come back to 3D. So in 2D, the condition for the two vectors to be parallel is that theta must be equal to theta prime. So the moment theta becomes equal to theta, see that alpha is equal to alpha prime, beta is equal to beta prime, and gamma is anyway equal to gamma prime, which in this case is 90 degrees. These two are both 90 degrees. Okay. So this becomes the condition. Okay. So the two vectors, for them to be parallel, this is the condition in terms of alpha, beta, and gamma. Now, once you apply that alpha, beta, gamma thing, you can see that if the vectors in 2D were given as ax I cap plus ay j cap and bx I cap plus by j cap, this is what it meant. So again, these two equations can also be combined, and it can be written that vector E divided by its magnitude must be equal to vector B divided by its magnitude. Equation this equation, let's say equation 1 here, and this equation 2 here. Okay. So these two can be combined. So again, here also it is A cap is equal to B cap. Okay. We can understand why A cap is equal to B cap, because in this diagram, what will be A cap? It will be a vector parallel to A but of magnitude 1, and a vector B cap will be a vector parallel to B but of magnitude 1. So if A and B are parallel, then obviously A cap and B cap are parallel, and both of them have magnitude unity. So obviously the condition for them to be parallel becomes that A cap is equal to B cap. So the same thing now we extend in 3D. So in 3D, instead of just equation 1 and 2, which is for cos alpha being equal and cos beta being equal, we also have that the angle with the z axis is same for both of them. So cos gamma for A should be equal to cos gamma for B. So Ez upon A should also be equal to Bz upon B, apart from these two equations. So now combining these three equations, you can write it as a vector equation like this. Okay. And that basically means this. That basically means this. So this is how we express the condition for vectors to be parallel to each other. Okay. So this was one of the important things we saw. Okay. Then the other thing we saw was the dot product of two vectors. So dot or scalar product we saw that by definition, E dot B was product of magnitudes into cos of angle between them, but also in component form, E dot B became product of x components plus product of y components plus product of z components. Okay, so these were the formulae. And along with that, we saw a host of properties. There's commutative property that E dot B is equal to B dot A. Then we saw distributive property. This one. Then we saw unit vector. First of all, any vector's dot product with itself becomes square of its magnitude. And then we saw the unit vector property that I cap dot I cap is 1. J cap dot j cap is 1, but I dot j, for example, is 0. J dot k, for example, is 0. All these kind of things, some more properties we saw. Okay. So now coming back to one important application we saw was that if A and B are perpendicular, okay, then what happens? Their dot product is 0. So this is also like an important theorem for us. How to check if two vectors are perpendicular, their dot product should be 0. Whereas how to check if two vectors are parallel, their unit vector should be same. A cap should be equal to B cap. Or vector A divided by mod A should be equal to vector B divided by mod B. Whereas if two vectors are perpendicular, what is the easiest way to check that their dot product should be 0? Okay. And finally, to find the angle theta between two vectors A and B in component form, we can make use of this formula that cos theta is equal to dot product divided by product of magnitudes. Okay, so these were the important things that we learned in relation to So these were the important aspects that we learned in relation to scalar products or the dot products. So I'll just minimize this for a moment so that you can go through this. All right, so now let's come to worksheet 1, and I'll start with some of the questions. So a lot of you have sent me the question numbers where you have doubts. So I'll look into those to begin with. Worksheet 6, assignment 6, whatever. Let's do discussion of some of the questions. Yes, I have got a request from somebody for discussion of question 1, so I'll start with that. I'll be discussing all the questions you have sent me for doubts. But anyway, let's start with this. So in this two vectors A and B are given, and we want to find their resultant's angle with respect to the x-axis. Okay. So given vector E is 4i cap minus 4i cap minus 2j cap plus 6k cap. And vector B is given as I cap minus 2j cap minus 3k cap. In this, so to find the angle of the resultant R of A and B, with respect to x-axis. Okay. So it's very simple. It's just the concept of this thing, direction cosine. If the resultant is having the three components Rx, Ry, and Rz, then angle alpha with the x-axis for it, let's say, with respect to x-axis, that it becomes such that cos alpha is equal to Rx upon magnitude. So let's work that out. So for this two vectors, you can first of all see the resultant, which is A plus B, is just add the two vectors. So 4 plus 1, that's 5 I cap, minus 2 minus 2, so that's minus 4 j cap. And finally 6 minus 3, so that is plus 3. This is the resultant. Okay. So the magnitude of the resultant is becoming how much? Becoming root of x square plus y square plus z square. You see that is root of 50. So now you can see that therefore for this cos alpha is 5 by root 50, or in fact that is equal to 1 by root 2. So you can see that alpha is cos inverse of 5 by root 50, and that is cos inverse 1 by root 2, which is in fact 45 degrees or 5 by 4 radians. So any of these answers is correct. Now in the options which are given to you, it is this option. Just mark that. Okay. In the options, it was just this simple option that is given to you, but otherwise you can reduce it further and work out that it becomes in fact 45 degrees or 5 by 4. Okay. So hope this question was clear to all of you. So that was question number 1. Now next I have received a request from somebody for question number 4. Okay, so I am going to be discussing question number 4. So beta gamma nikalna nahi hai na. Minus in this we don't have to worry about beta and gamma because the question is asking only the angle with respect to the x-axis. If it was asking what is the angle with respect to y and z axis, then I would have found out gamma. Okay, I have also received some doubts in question 2 and 3, so we'll discuss. Understood, Manas? Okay. All right, so let's come to question 2 now. So somebody has asked. Okay, so for question 2, we'll have to solve this way. Again, in question 2, 2 vectors are given to us, A and B, and it is asked to find a third vector, let's say C, such that magnitude of that third vector is equal to magnitude of B, and its direction is parallel to B. So this is what we have to do. Now I'll just give you the vectors which are given. But more importantly, we'll discuss about the method of solving this. Okay, so the vectors A and B are 3i cap and 4j cap. That is E. The vector B is 7i cap plus 24b. You can start by using this now, that magnitude of B is equal to magnitude of the vector C, which will just become mod of this vector B, which is given 7i cap plus 24j cap. That is square root of 7 square plus 24 square. Okay. So as you can see, this will give you square root of 625 or 20. Okay. So now I have the information that magnitude of C is equal to 25 units. And I also have the condition that C is parallel to B, which is 3i cap plus 4. Now see, you can do one thing interesting over here. One method is that, recall, if vector C is some multiple of vector E, that means that mod C is equal to n times mod A, and C is parallel. Here, of course, n I'm assuming is a positive number. So I can do it by this method without using unit vectors. I can do this. That C is a vector जिसका magnitude 25 है, but इसका direction A से parallel. That means C and A के बीच कैसे relation होना चाहिए? This means that C and A should have this kind of relationship. It should have a relationship of one vector is a multiple of another vector. Okay. Now you can see that mod A is magnitude of this vector. It is a very familiar vector, which is 5. And mod C we just saw was equal to mod B, which is 25. So that means you can see that C should be equal to 5 times. That's it. A vector which is parallel to A but 5 times its magnitude, it has to be this. So the vector C here has to become 5 into 3i cap. So that's becoming 15i cap plus 22. Now this is just one of the methods of solving. Okay, I'll take you to another method also. But you can just first go through this thing and understand this. Okay. So first we use the two things which are given about the vector C in the question. One is that it has the same magnitude as B, and the other is that it is parallel to E. So from the fact that mod B is equal to mod C, we got the magnitude of C to be 25. And then from the fact that A is parallel to C and A itself has a magnitude of 5, whereas C has a magnitude of 25. So that means the vector C must be a multiple of A, which is 5 times. Only then it will have the magnitude of 5 times 5, which is 25, and it will have the direction parallel to it. It's very simple in this respect. Okay. Now also try to do this using the unit vector concept that we just discussed a minute back. Okay, Dhruv. But the slide above, Dhruv, is for question number 1. So we are doing question 2 now. That one was for question number 1. So you can take a look at it later if you like. You just concentrate on question 2 right now, and also do it by unit vector method. Try to solve this by unit vector method. Okay, so let's quickly understand this by the unit vector method. So the unit vector method is something like this, that you visualize the vector is suppose Sn. So E is just a vector of some magnitude. So then unit vector along E cap, which is vector E divided by mod A, that will become 3I cap plus 4j cap divided by 5. Now what will that unit vector look like? E cap. That will now look like this. It will look like a vector of same direction, but the line kind of parallel to this, but of magnitude only unit. So E cap will have magnitude 1. This length here, magnitude 1. Whereas the vector E itself was having a magnitude of 5. This was magnitude 5. So in comparison, now what is the vector C? And the vector C is having magnitude equal to 25 and direction parallel to E. So the vector C should over here now be a little difficult for me to draw in proportion, but I try. So a long vector like this, which will be like this, so magnitude 25. So now if I draw C's unit vector, that should be the same as A's unit vector. So C cap should be equal to A cap because they are parallel. So that means I can write the vector C as its magnitude times its unit vector, which is going to be nothing but 25 into E cap, because its unit vector is the same as this, and E cap is. So C is 25 times 3I cap plus 4j cap divided by 5. So this is another way of expressing the vector C. So here we are again using that concept that if two vectors are parallel, then their unit vectors are same. We're making use of that concept. So that's why C cap is replaced with A cap. So I'll just minimize this for a moment so that you can understand it by this one. Okay. So this is the alternate way of this question. Now, third question I'm not going to solve fully because it's a very simple question. In third question, you have to just apply the condition for the vector C to be zero. To be a unit vector. In question 3, vector C is given to you, or whatever, some vector is given to you. So in this question, given some vector where there is an unknown quantity C, you have to find that unknown quantity's value so that the vector is a unit vector. So 0.4 I cap plus 0.8 J cap plus some unknown quantity C K cap is a unit vector. So this vector is a unit vector, means that its magnitude should be equal to 1. Its magnitude will be how much? Square root of 0.4 whole square plus 0.8 whole square plus C square. They should be 1. So just solve for C. For it to be a unit vector, the vector's magnitude should be unit. So it's very simple. That's all it is. Okay. Let's come to question 4 next. So to find the angle between two vectors that are given to you. For this, it's the application of the dot product method. So this is what we were talking about a while back. So the vector E is I cap plus J cap, and the vector B is, sorry, not B cap, it's a vector B is 2 I cap plus 2 K cap. So we want to find theta, that is the angle between A and B. Yeah, Dhruv, at the end of the lecture, I'll show you, I'll give you the lecture notes. Right now, just concentrate on this, because unnecessarily you'll miss out. So cos theta by formula becomes E dot B divided by mod A into mod B, because by definition A dot B is AB cos theta. So from this definition we are getting this. Okay. So here what is A dot B? So let's first work out A dot B. So for these two vectors, the dot product is product of x components. So that is 1 into 2 plus product of y components. So that's 1 into 0 plus product of z components, that's 0 into 2. Okay. So this is nothing but 2. And then for this, what is the magnitude of the vector A? It is square root of 1 square plus 1 square. So that is root 2. And for this, what is the magnitude of the vector B? It is square root of 2 square plus 2 square. So that is 2. So now what is cos theta? Cos theta is A dot B, which is this one, divided by mod A, which is this one, into mod B, which is this one. You can see this now. So theta is cos inverse of half, which is 60 degrees, or pi by 3 degrees. Okay, so this is like going to be a very standard kind of situation for us from now on, especially when the vectors are in 3D. So notice here, this is in the xy plane, this is in the xz plane. So we cannot really draw the vectors and geometrically find out how much the angle is, like we were used to doing in 2D component method. So we have to relate this by the dot product method. Then again, I'm not going to discuss fifth question. It's a very direct question. Okay. So in question 5, you are given mutually perpendicular force vectors. So if they are mutually perpendicular, you can just take them to be along the x, y, and z axis. So you can write your force vectors as 3i cap, 4j cap, and 12k cap respectively, and then just use component algebra to find the result. So that's the fifth question. Okay. Now sixth is a question which I want to discuss actually. So let's come to this. So vectors A and B are given. These two vectors are given to us. Now various options are asked, like whether they are parallel, how much the magnitude of A is, what is the ratio of magnitude. But one thing you can see very clearly, observation is showing here that vector B is equal to 2 times vector A. So that means, obviously, because that's the case, B is parallel to A. That also means that B cap will be equal to A cap, or B divided by B will be equal to A divided by A. Okay. And of course, from here you can see that mod A is equal to 5, whereas mod B is equal to 10. So this itself is showing that mod B is equal to 2 times mod A. So this is one thing which is there in one of the options. This is also one thing which is there in one of the options. And this was also there in one of the options. That's how it's supposed to work. Yes, Nikita, to answer your question, you will get the question paper on the website only. You will have to log on to the student zone to your test thing, and it will show you the, like it showed upcoming tests last time. So now it will also show previous tests that you have taken. So the previous test, it will show you your marks and the questions you got negative marks in and the questions you got positive marks in. From that, you will be able to see the questions and the solutions. Okay, let's come to question 7 next. 7 is also a fairly straightforward question, but it's the first one we're doing of this type, so I'll discuss. Perpendicularity condition on two vectors. So given A is given with one component unknown, which is the x component, C I cap minus 4j cap plus 2k cap. And the vector B is given with, so the vector B is given with x and y components known, but the z component unknown. So 2i cap plus 4j cap plus that same unknown c. Now they are asking the value of c so that A is perpendicular to. So perpendicular condition, we have to just apply the idea that dot product is. So this implies that dot product of A and B should be C. So that implies that Ax into Bx plus Ay into By plus Az into Bz should be C. So just substitute now. So you can see 2C minus 16 plus 2C. So C value will be 4. This is the okay. So fairly straightforward. 7th question. So note down that part and let's come to 8th question. The 8th question is also kind of making use of this concept, but along with another thing that the vector asked for should be a unit vector. This is one vector given, then another vector given is this. And then the question is asking, then a unit vector perpendicular to the resultant of A and B is which one? Okay. So this is a question we'll have to do backwards from the options. So the first thing is, since they are talking about a unit vector, what we should do here is first check if the vectors in options A to C are unit vectors. And from that you will see that this is not a unit vector, whereas these two are unit vectors. So you can see that for the option A, the magnitude of this is this. That's not equal to unit. So therefore, it is not a unit vector. But by the same logic, when you do option B and C, you will see that they are unit vectors. But now also check, secondly, check if the vector in option B and C now, because you ruled out option A. So in option B and C, check if the vector is perpendicular to the resultant, where resultant is A plus B. So resultant of A and B, if you work out, you can see here that the resultant will be 8 plus 8, so that is 16 I cap, minus 6 plus 8, so that is plus 2. So this resultant 16 I cap plus 2 J cap. Now let us see what we have in option B. We have some unit vector, let's say n cap, which is I cap plus 8 J cap divided by root 65. You can see here that n cap dot r cap will definitely not be 0. So therefore, this is not perpendicular to the result. Okay. But if you look at the other one, we have, let's say, some other unit vector m cap. It was given as I cap minus 8 J cap upon root 65. Now you take the dot product of this with this. So n cap dot r cap or dot r vector. You will see it will become 16 minus 16 upon root 65. Just 0. So the dot product is 0. So it implies that this unit vector m cap is perpendicular to the result. So therefore, we have option C as the correct. That is, m cap is a unit vector perpendicular to the resultant of AM. So that's why this kind of question becomes a little lengthy, because you have to match each of the options in terms of two factors. That first of all, you have to check whether they are unit vectors or not. So the first option A gets ruled out because it's not a unit vector. It is a magnitude of less than 1 by root 65. Option B and C are unit vectors. Now from B and C, you have to select if any one of them has a property that it is perpendicular to the resultant. So the condition for perpendicularity, this condition is that whatever unit vectors dot product with R should be 0. Whatever those two unit vectors are, their dot product with R should be 0. Okay, so this is the 8th question. Hope this is clear. Now moving on to the integer answer type questions. In 9th is a direct question. I think all of you will be able to work it out. Yeah, Pranay, you asked a good question. How will we do this if this was a subjective question? Now, the answer to that is a little bit complicated. Yeah, I'll explain to you how we do that if it is a subjective question. So, if we were not back checking from the options, then it becomes a more difficult question. Suppose the question is like this, that given this vector R, which is equal to whatever it was, 8, so it's 16 I cap plus 2 j cap. Now, if I ask you, find a unit vector n cap perpendicular to R. Now the question is, now can we do this? The answer is no. Okay. There are infinite such unit vectors. Which are perpendicular to another unit vector. Let's understand why infinite unit vectors exist. Because think in terms of 3 dimensions. So just think of any plane that cut, or any plane that is by this vector R perpendicularly. So you realize that infinite such vectors, unit vectors, lie in that plane. So we cannot really draw any one of them. Understood? But if we restrict the idea to 2 dimensions, then we can say that yes, there is 2 particular vectors which are perpendicular. Just a moment, people. I think I have lost connectivity. So just take a break of a minute or so. See, I have partially lost connectivity here. So just give me a moment. Okay, so people just restarting from that point onwards now. Just a moment, I will share the whiteboard screen again and we'll get started. Just give me another minute or so. Nobody else, please share any screen at this point of time. Okay? Okay, so we should be back online now. All right, so this is what we were discussing last. That suppose the options were not given to us in this, and we just had an arbitrary vector like this one, 16 I cap plus 2 j cap, and we asked for to find the unit vector perpendicular to R. I have to understand that there is no such single unit vector possible. Okay, the important thing here is there are infinite such unit vectors. Because what happens is, just visualize this now. Visualize your vector R as this one, suppose. Now think of this vector cutting through a plane like this, perpendicular. It's cutting through a plane like this, perpendicular to that plane. So within that plane, there are infinite such unit vectors, or infinite such vectors which are lying. Because so why are they infinite such vectors which are perpendicular to R in general? Because any vector lying in a plane intersected by R perpendicularly is like this. It is perpendicular. However, okay, so this is the general problem. Okay, so that is why we cannot define. In fact, later in mathematics, you see a more interesting version of this kind of thing, which is like more complicated vector algebra. You can express all these vectors as a family of vectors. They have a certain common property that they lie in the plane which is perpendicular to this particular vector R. So they are expressed by an equation which represents infinite vectors, but through a certain relationship, and that relationship is called the family of vectors. Okay. But here we don't have to get into this. Okay. However, suppose within the same question I asked that you want to find a unit vector in the xy plane. In the xy plane perpendicular to the vector R. Now the answer for that is, okay, you see that there are two such unit vectors exist. only two edges. Instead of infinite, there are only two edges. Why? Because now I'm restricting my solution to a two-dimensional plane. Okay. So going back to this, my vector R was 8 I cap plus 2j cap. So in my xy plane, within my xy plane, the vector R or something like this. Where this angle is, let's say, some theta. So you can see from here that tan theta is equal to 1 by 4. Okay. So now there will be two such unit vectors within this plane which are perpendicular to this. One will be like this, the other will be like this. So this angle is 90 and this angle. So this will be one unit vector, let's say n cap, and this will be one unit vector. Okay, so now how to find n cap and n cap? So this is a very interesting problem in itself. We want to find n cap and n cap. How to find them? So I'll leave you with a hint on how to do this, okay? Because this is a very interesting problem on its own. So what we do for this is first find r cap, which is the vector r divided by its own magnitude. Okay. So that will be rx by r I cap plus ry by r j cap. So जो भी values rx और ry क्या है above, use those values and from that you get this. Now next what we want to do here is we want to understand that this r cap is actually equal to cos theta I cap plus sin theta I cap. So by combining this and this, you understand that cos theta is nothing but rx by r and sin theta is nothing but ry by its magnitude. Now you look at the unit vector n cap. Now for n cap, what is the angle with the x-axis? It is 90 plus theta. If you look in the diagram above, this vector, how much angle is making with the x-axis? This whole angle. This angle is how much? It is 90 degrees plus theta. So that is becoming how much? Minus sin theta. So that is minus of ry by r. And the x component is this. For the vector n cap, it has some x component and some y component. So the x component will become how much? Become just this, because magnitude of this is, remember, 1. So x will just become cos of the angle with the x-axis. So this is. Whereas the y component will be sine of this angle, which will become plus cos theta, which will become plus ry. So what is my vector n cap? It is this one. It is minus ry upon ri cap plus rx upon r j. And if you look closely in the diagram, the vector n cap is just minus of n cap because it's equal and opposite. So you don't need to separately calculate them. Okay. So this is how in a subjective situation we can calculate this by just using unit vector relations. Unit vectors and component element. So just make a note of this, people. Okay, people, so hope this concept is clear. Yeah. Okay, so that's about this concept. So you can use this method and you can see how you can arrive at that question directly. Now let's move on to the other questions in the worksheet. Right, so next question. So ninth question in the worksheet is very direct, so I'm not going to get into it. It is just going to find the direction cosines to directly. Now 10th question, let's look at it. However, that's also quite a simple question actually. So question 10 is something like this, that the resultant sum of two displacements vectors of magnitude 6 and 8 respectively is 10, then their dot product is how much? So if mod A is equal to 6, mod B is equal to 8, and mod of A plus B is equal to 10. Now from that what we can see, that since 10 square is equal to 6 square plus 8 square, that means mod of A plus B happens to be equal to square root of A square plus B square, which means that they are perpendicular vectors. Cos theta is equal to 0 or theta is equal to 90 degrees. So their dot product will become how much? It will become 0. So that's your 10th question. Very common type of question, but very straightforward type of question. Okay, that some information is given as for A plus B, and from that you find out how much is cos theta. In this case, cos theta is 0. So A dot B becomes 0 accordingly. Then 11th question is also very direct. Direction cosines are given to you. So in 11th question, cos alpha is given, cos beta is given, and cos gamma is given, and the magnitude of the vector is given. So from that we have to find components. So you can see that the x component will just become A cos alpha. The y component will just become A sin alpha. Sorry. Yeah. A cos beta. And the z component will simply become A cos gamma. You substitute these things here and you can answer. So that's your 11th question. Now moving on to 12th. So in 12th, what is happening? The dot product of two vectors is given. E dot B is given minus 20. Okay. And magnitude of A is 4 and magnitude of B is 5. And from that it is now asked what is mod of E plus B. So this is also fairly self-explanatory. Use a combination of triangle law and dot product. Okay. So from these two informations, you're getting E dot B should be equal to EB cos theta. So minus 20 should be equal to 4 multiplied by 5 into cos theta. So you can see cos theta should be equal to minus 1, which means that they are anti-parallel vectors. Theta is 180 degrees. So the moment that is the case, you actually know that mod of A plus B. You don't need to expand by this. It's just the difference of it. You know it should be 1. But if you want to expand, you can do that. You can substitute that here. And you can use the formula. इस केस में cos theta minus 1 substitute करें. So this will become 4 square plus 5 square minus 2 into 4 into 5. So still that will give you this. But obviously the moment you see that cos theta is minus 1, it should strike you that they are anti-parallel vectors. So this should become like this. Alright. So this is fairly straightforward also. Now coming to question 13. So in question 13, it is given to us that E plus B, that is the resultant sum of two vectors, is perpendicular to A minus B. And it is given to you that mod of E is equal to 5. So from that now you have to find mod of E. So just apply the perpendicularity condition now. So if two vectors are perpendicular to each other, then it implies that their dot product should be 0. Okay. Now apply the distributive property here. So E dot A minus E dot B plus B dot A minus B dot B is equal to 0. Okay. Now next step, A dot A is nothing but magnitude of A square. A dot B is the same thing as B dot A. So you are using the commutative property. So this can be written as this. So this term and this term cancel out. So here you use the distributive property that B dot A can be written as A dot B. And finally, that A square minus B square is 0. That means A is equal to B or A is equal to minus B. Now this can't happen here because A is a magnitude. So only this solution is possible. So that means A is equal to B or magnitude of the vector E is equal to the magnitude of the vector B is equal to 5. Okay, so this is the application of dot product. It is actually giving you an important concept that whenever the sum and difference of two vectors are perpendicular to each other, it means by definition the two vectors involved must be equal in magnitude. All right, so this is clear, I hope, to everyone. Just going through your messages once more. Yes, Rakshit, that is correct. You can also use parallelogram law in question 13 and apply the condition that a rhombus is the parallelogram which has diagonals perpendicular. So whenever we have a parallelogram with perpendicular diagonals, that means it is a rhombus. So in terms of the vector parallelogram, if it is a rhombus, it again means this condition, that mod A is equal to mod B. Okay. Good, Rakshit. Okay, now 14th question is just formula based. The language might have confused you, that's all. There's nothing difficult in it. So in question 14, it says two unit vectors are at 127 degrees. Okay. So their scalar product or dot product is how much? Okay. So just visualize like this, that you have one unit vector like this and another unit vector like this. So this unit vector is, let's say, m cap. This unit vector is n cap, and the angle between them is 127 degrees. So m cap dot n cap will just become cos theta, okay, because their magnitudes are unity. So dot product of two unit vectors is just cosine of the angle between them. So use this AB cos theta. But यहाँ पे क्या दोनों unit vectors है. So A and B are both how much? They are unity. So it is 1 into cos theta or cos 127 degrees, which is minus cos 53, which is minus 3 by 5. So that should become your answer. Okay. And question 15 is like a repeat question actually. In question 15, it is given to you that magnitude of A plus B is equal to magnitude of A minus B. So this is something we know very well by now. Diagonals of a parallelogram are equal when it is a rectangle. So that means theta is equal to 90 degrees or cos theta is equal to 0. So if that's the case, then A dot B by definition is equal to 0. So very simple question there, that one. Okay. So right people, this concludes the worksheet discussion. Okay. And a lot of little tricks you would have seen that we use in the application of dot product and direction cosine and things like that. Okay. Now, for the last part of the lecture, we'll understand another important thing, okay, which comes from dot product. Okay. So we will look at interpretation of scalar or dot product in terms of projections. In terms of projections. Okay. So suppose we have one vector which is like this, and another vector which when we draw from the same origin as A works out like this, and the angle between them is theta, and their magnitudes are B and A respectively. Now what is A dot B? It is AB cos theta, which we can also write as the product of these two quantities, magnitude of A into B cos theta. Okay. Now if you simply drop a perpendicular from B onto A, as if A is your x-axis, you can see that this component of B is nothing but B cos theta, and similarly this component of B is nothing but B sin theta. So we can think of this like a component of B parallel to it and a component of B perpendicular to it. So they are projections. So what we can do here is that the vector B can be what we call resolved into two components such that, let's say we just call this B parallel, which is B cos theta in my diagram. This is the component, or you can say projection, of the vector B along the vector E. Instead of along the x-axis, now that is the vector E. X-axis may not coincide with it. It all really depends on where I have placed the x-axis. Right? Just a moment. I have somebody here. With him got logged out. Hopefully he's back logged in now. Yeah. No, he's not logged in. Alright, so the vector B and the second component, which is like this, B perpendicular, which is B sine theta. So this is the component of projection of B perpendicular to E. Okay. So first of all, this is the concept of projections. Now you can see that interpretation of dot product. Definition is AB cos theta. You just think of it like E multiplied by B cos theta. Or in other words, it is E multiplied by the parallel component of B. So that's one way to interpret dot product. So E dot B can be interpreted as magnitude of E vector multiplied by the projection or component of B along the vector. So that is why, for example, when we talk about a definition like work done, it is force into displacement in the direction of work done. In the direction of force. Okay, then it becomes obvious. Right? For example, when we define work done as F dot S, so this becomes F into component of S, which is parallel. So if you are applying a force in this direction on a body, but the displacement is happening in this sort of direction. Okay. So this becomes Fs cos theta. So later in a chapter of work energy, we will see that this is the definition of work done. When the force and displacement are not in the same direction, when there's some angle between them, the definition becomes Fs cos theta. So in that, basically, what is the interpretation? It is force multiplied by the component of displacement along the direction of force. Okay. So this becomes something important, and through this we'll see another application of dot product also. So just note this down first. Okay, this is pretty important. Okay. So if you see any two vectors which are not parallel to each other to begin with, they can, so the second vector can be divided into two components like this, one which is parallel to the first vector and the other which is perpendicular to the first. So the parallel one is B cos theta. Okay, people. So hope the concept of this projections is clear. Yes. Okay. No, so that is the idea, beta. What you are asking now, Dhruv, why we take cos theta and not sin theta? Because we want to define it this way. We want to define it as A into parallel component of B. We don't want to define the quantity as A into perpendicular component. अगर A into perpendicular component लेना होता फिर मैं उसको AB sin theta define करता. But यहाँ पे मैं चाहता ही हूँ कि वो quantity कैसा हो. It is the magnitude of the first vector into the projection of the second vector along the first one, not perpendicular. That is why it is defined as AB cos theta. So it's the other way around, because work done is force into displacement in the direction of force. That is why it should be defined by F dot S, and that is why it should be the dot product should be defined as cos theta instead of sin theta. Okay. So now let us understand how to find the projection using dot product. So next thing we will see is, therefore the projection of a vector, let us say B, along another vector E, let's say, can be found using the dot product. So this becomes an application of dot product. Okay. So for example, so you can see that A dot B is equal to AB cos theta, or what we define as A into B's parallel component. Therefore, B's parallel component, or what is B cos theta, is nothing but A dot B divided by. This is how we find the parallel component. So for example, I have, let's say, this vector B, which is I cap plus J cap plus K cap, and I have the vector E, which is 2I cap plus 2J cap. Now I ask, find the component of the vector B along the vector E, and I also ask the component of vector E along the vector E. So how to do this now? So the first part, B's component parallel to A is nothing but B cos theta. So it is nothing but A dot B divided by mod. Now just work this out. How much this is? Okay. So you can see from the two vectors given, A dot B will be how much? 1 into 2 okay, plus 1 into 2 plus 1 into 0. So A dot B is 4. Okay. And you can see mod A is how much? 2 and 2, so it is 2 root 2, whereas mod B was how much? It's root 3. Okay. So now just substitute from here. So this just becomes 4 divided by 2 root 2, which is, that's it. Now similarly work out the second part, component of A along B. Work out the second part yourself, people, from this. Very good, Manas, that's correct. Yes, good, Vaishnavi, that's correct, beta. Yes, Harpriya, correct. Nikita, Atharva, correct. Both of you, so good. you understood that अभी जैसे जैसे हम लोग ने B का component निकाला था along A. Now similarly, suppose A is this vector and B is suppose this vector. Now it doesn't matter that B is actually shorter than A or A is longer than B. It doesn't really matter. Still A has a component along B and B has a component along A. So अगर A का component निकालना है, then in along B's direction, I have to drop this perpendicular from me. Drop this perpendicular, and this quantity here, this will become A's parallel component, or in other words, it will become A cos theta. This is the second part. The second part, I want to find A's component parallel to B. So that is A cos theta. So that is just now A dot B divided by mod B instead of mod A. That's it. So A dot B was 4 and mod B we saw was √3. So that's it. That's the answer. So this is vector A's component along the vector. Okay. So hope this is clear, people. Now from this, another interesting thing you can see is that once you have got one component, the other component can be calculated very easily. So going back to our earlier diagram, suppose this was my vector E, this was my vector B. So what we did is we dropped a perpendicular onto this, and we also dropped a perpendicular onto this perpendicular line. And from that we got the components of A along this direction, rather this as B cos theta, which was the parallel component, and we got this as B sin theta, which is the perpendicular component. Okay. Now notice something interesting, that this relation holds. Okay. This relation holds because they are mutually perpendicular. This component and this component, they are mutually perpendicular. That's why this relation holds. Okay. So what we do is, to find the perpendicular component, what we do is we first find B parallel from A dot B divided by 1, and then from that we find B perpendicular equal to root of B square minus parallel components. So for example, in the previous question, in this question, where the vector B was I cap plus j cap plus k cap, and the vector A was 2i cap plus 2j cap. So we saw using this, B's parallel component had come out to be √2, and magnitude of B was √3. So therefore B's perpendicular component is just becoming square root of 3 minus 2. So now we have both the components. So the components of B parallel to A is equal to √2, and perpendicular to A, that is 1. So this is a little trick that we can use to find the perpendicular component also. Not directly from dot product, but from dot product first we find. So to find B perpendicular, what we do is first use dot product to find B parallel, okay, and then substitute this B parallel in the equation, and find the perpendicular. Okay, people, so hope this is clear. So now just applying this particular concept to the same question we did above, first to find the parallel component of B, and we've seen it had come out to be √2. whereas the magnitude of this vector b was root 3. So now use it to find the perpendicular component, and this is. So this is my step 1 which I have done earlier. I found the parallel component using the dot product method. And then I substitute that, that's my step 2. In that equation, that b perpendicular is square root of b square minus b parallel square. So it becomes that relation. Okay. So now the final thing is that sometimes we want to express these projections as vectors, okay, in I cap J cap notation. So the final thing here we'll see today is to express the projections that we just discussed in vector form, in vector notation. Okay. That is component vector notation. So that means I want to find B parallel as a vector, and I want to find B perpendicular as a vector. So that's very simple. There's nothing complicated in that. You can see that if this is your vector E, this was my vector E, and this was my vector B. Okay. And this angle was theta. Now, when I drop this perpendicular here, I'll be expressing this as my parallel component. So only thing is now I want to express this as a vector. Okay. And similarly on this side, I'll drop the perpendicular and I'll express this quantity here again as a vector with the I cap J cap notation. I want to find out these. So अभी मैं obviously क्या समझ सकता हूँ कि what is the unit vector in this direction? See, what is the unit vector along this? It's A cap. E cap is a unit vector along this direction. So E cap is vector A divided by its own magnitude. Okay. And you can see that the parallel component will have a magnitude of B cos theta. But what about its direction? It's along E. Just like this. Okay. So this is the component of magnitude B cos theta and direction along E. Okay. So that becomes the case. So it's very easy. So going back to that example where A was 2I cap plus 2J cap and B was I cap plus J cap plus K cap. So we saw that the magnitude of this, which is B cos theta, get seen was root 2. And this had come by taking E dot B divided by mod A. Okay. But now, unit vector of E is nothing but vector E divided by its magnitude. So that in this case is 2I cap plus 2J cap divided by 2. That will become 1 by root 2I cap plus 1 by root 2. So ये मेरा unit vector A cap होगा और ये मेरा parallel component का magnitude होगा. So therefore, expressed as a vector, the parallel component is how much? It is just B cos theta, the magnitude amount, multiplied by the unit vector along E. So just substitute. So this had come out root 2, and this is 1 by root 2 I cap plus 1 by root 2 J cap. So this is coming out to be I cap plus J cap. So this becomes the parallel component expressed as a vector quantity in in the I cap J cap notation. It becomes like this. Okay, so this just minimizing you for you to understand this in detail. But it's basically just the same thing. You're just expressing it as a vector. So now a vector can always be expressed as some magnitude into its direction, which is expressed as a unit vector. So abhi unit vector kaun sa hai? It is the unit vector of A only, na? Because it's the direction parallel to the direction of B. Yeah, so I'm explaining this again. So let's actually go one slide up and understand this. So we want to express the parallel component and perpendicular component as vectors using the component notation. So come back to the diagram here. So if this is the vector B, which is lying at an angle theta to the vector A, then a component of that along the vector A will be this vector here pointing in the direction of A, but having a magnitude of how much? B cos theta. So that parallel component expressed as a vector will become magnitude, which is B cos theta, into its direction, which is given by the unit vector A cap. So that's how we express the parallel. A unit vector A cap kya hoga? Vector A divided by its magnitude. Okay. So now just imagine in this example, ये जो vector A है वो ये वाला है. It's 2 I cap plus 2 j cap. The vector B है, that's this one, I cap plus j cap plus k cap. So what is this B cos theta component? It is nothing but from dot product we had found out A dot B divided by A, it's root 2. Whereas what is the unit vector along this direction? A cap. It is nothing but A divided by its magnitude. So that becomes this. So now the vector, this one, B parallel wala vector, it becomes what? It becomes its magnitude, which is B cos theta, into its unit vector, which is A cap. So the vector B parallel is nothing but its magnitude into its direction as a unit vector. So its magnitude was nothing but root 2 from dot product, and the direction A cap is just coming by this. A cap you can see is vector A divided by mod A. So that's this. So multiply that by this. Okay. Now understood this. Now the final step, B parallel plus B perpendicular as a vector sum will become how much? The vector B. So now from this we can calculate the perpendicular component of B as just the original vector B minus the parallel component. So now if I want to find the perpendicular component here, it is the original vector B minus the component parallel to it. So the original vector B was this I cap plus j cap plus k cap, and the parallel component is this I cap plus j cap. So their difference is how much? It is. So this is becoming the. So again in the diagram above you can see why this is happening. This vector B can be expressed as the sum of this vector plus this vector. So this vector is coming from the dot product method, and the other vector will just come by subtracting this one. Alright people, so this is the complete lecture here. So we'll conclude here today. Okay. So I'll be sending you another worksheet with some applications of projections. But now we are coming very close to the end of vectors. So you can also, one of the things you should start doing is going through each and every part of your vectors, this thing module very carefully, especially the illustrated examples which are there in the vectors module, or that useful mathematics of physics that starts with vectors. So the illustrated examples, and gradually start doing the exercises. I'll be sending you a list of questions also to do from the exercises, and of course a list of questions as a worksheet. Okay, so that's it for today's class. For the sake of truth, I'm just sharing the question number 1 from the worksheets solution, because you missed that earlier today. Yeah, so this is the solution of question number 1. Okay, and rest of you, that's it.